Hello. Today we have the question maximum length of pair chain description. This one, and we are given a pair and pairs, and in each pair we have a left element and right element, where we are given that left element is smaller than the right element, and we are also given. So for example, we have pair of two, which have C and D elements, and we have pair one which has elements A and B. It is given that B is smaller than C. Okay, it means that P1 appears before P2. Okay, now a chain of pair can be formed in this fashion, because AB occurs after AB, CD occurs, and B is smaller than C. So a pair of chain can be possible, and we have to return the longest chain that can be formed. And it has been said that we do not need to give use up all the given intervals. You can select pairs in any order. Okay, the last line means that if there is a pair, for example, this one we have 1 2, then we have 2 3, and here we can see that 2 is not smaller than 2, so we cannot have this pair in our interval, so we have to remove this. But we can have 3 in our pair of chains, so we can have the chain like 1 2 and then 3 4, and 2 3 will not be in our answer, so we have longest chain of two pairs. See, longest chain of two pair, 1 2 and then 3 4, because this 2 is not less than not greater than this 2. Okay, the next element should be greater than the previous last element. Now we have this another pair, we have 1 2 then 7 8. Okay, then 7 is possible to be in the chain, but then we have 4 5, we have 4 5. So while checking 4 5, we can see that 1 2, after 1 2 we can have 4 5, and after 5 we can have 7, and we can have 8 also. So in that condition we can have we can have our longest chain possible. Okay, now now how do we solve it? Okay, so there are many solutions to this, but my approach is, like, we have this array, we have this 2D array. Okay, we are given this 2D array, we have this in the form of 2D array. Now we know that the number of rows can be, there can be n rows. Okay, but the columns are at most 2, 1 2 1 2 and 1 2. Okay, see here number of rows are 3, but the column are exactly 2. Here also we have number of columns, number of rows to be 3, and we have exactly 2 columns, because we are given a pair, and pair can have at least at most 2 elements. That means we have at most of 2 columns. So now the approach is such a way that we have to sort the pairs, okay, so we are sorting uh, this pair. So our sorted pair would look like something. uh, Let me show it to you. 1 to 1 comma 2, then again it would be 2 comma 3, and then it would be 3 comma 4. Okay, so from here we can clearly say that this one would not be our answer, and our answer would be this one. So we have a maximum of two pairs. Now if we take an example of this one, 1 2 7 8 4 5. If we have an example of this one, we have an example of this one. If we sort this array, then we have the resultant array 1 2 4 5, and then 7, and then 8. Okay, so this one is our sorted array. Let me zoom it up. Okay, now after sorting, this is our resultant array, and we can clearly say that 1 2 3, all the three pairs can form a chain. So we have a maximum of 3 pairs in this chain. Now how do we approach that? We first sort the array. Okay, we first sort the array, and then let me delete this one. Okay, we first sort the array. See, we have sorted the array. Now now let us take a, let's say, a variable. It has, right now it has 1 2 as our pair. Okay, it has stored 1 2 as our pair, and it will check the next pair 4 5. Okay, it will check the next pair 4 5, and then it will check is 4 is greater than this 2. If it is greater than this 2, we'll update the var to be 4 5. Okay, we'll update the var to be 4 comma 5, and we'll increase our counter to 2. After that, we iterate to this pair, and again we'll check is 7 greater than this previous 5. If it is greater, we will store var with 7 8, and we'll update our counter to 3, and at last we'll return the number of maximum pairs. Now let us check the code. So this is our code. We have first sorted the 2D array. This is the way we sort a 2D array using the comparator class or interface. Now we have the chain length starting at starting. We have the chain length of 1. See here also we have the chain length at the starting. We have right now in the starting, whatever may be the condition at the starting, the chain length will be 1. So we have 1 as our chain length. Now we are storing the last pair in the last in this variable. In this variable we are storing this current pair. Now we are traversing each time, sorry for this, for I equals to 1. Okay, so we are traversing from 1th in the row. Okay, because we have taken the 0th row right now, so we are traversing from first row and till less than pair dot length, and we'll increment till each iteration, and we are checking is pair of I comma 0. Okay, means 1 comma 0 is greater than this last one, last index, this one, 0 comma 1. Okay, if it is greater, then we will increase our chain length and we'll update the last this last end variable with this pair. Okay, pair 1 I comma 1. Okay, because right now we are checking the last end one, and we are, for example, let me again write down. We have 1 2, then we had uh, let's say 4 5, and then we have 7 8. Okay, so see here, this 1 2 0, this is 0th column, this is first column. So we are comparing this 0th column and first column with ith row. This one is our second row, ith row, and 0th column, that is 4. So we check that 4 is greater than 2. 4 is greater than 2. So after that what we do, we increment our chain length counter, and then we store this 5 5 as our last end variable, like this one, I comma 1. This one is ith 1th column and ith row. So 5 is stored in our last end, and in the next iteration we again check I comma 0. So I is in our third row, and 0 is in pointing to 7. So we are checking 5 with 7, and 7 is greater than 5. So again it will increment the chain length, and it will return total number of chain length possible. Okay, so let us run and check if it runs or not. No, we have some error. What is that? Okay, few what? Okay, yeah, it is getting accepted. Let us submit. Yeah, so okay, so see, this was our game, and here the time complexity is big O of log n. Log n. Why log n? Because we are sorting the array. We are sorting the array plus big O of n, because we are traversing n times. So it will be big O of log n plus big O of n. And our space complexity is just big O of 1. Why big O of 1? Because we are using just one this variable. So there are no more, and in each iteration we are not creating a new variable, we are just updating the old variable with the new variable. So we have space complexity of constant big O of 1. So we have a constant space complexity, but here I think I don't know why we are getting a large number of space. Okay, but see, our runtime is quite good, 11 ms. So that was all. Hope you liked the video. Thanks for watching.